Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video we're going to build a simple stock screener in Python, so let us get right into it. Alright guys, so what is a stock screener? Now a stock screener is basically just a tool that allows you to look through a bunch of different stocks and find the ones that match your criteria that you determine in advance. So let's say you look through the S&P 500, there you have 500 companies, and you want to find those that match your criteria. For example, you might say, I want to have a company or I only want to see companies that have a PE ratio of less than 30, for example. Or you want to have a PAC ratio of less than 2. Or you want to have a moving average over the last 30 days of whatever. So it's important that you know what your criteria is, and the stock screener can then help you to just look through a bunch of different stocks automatically. You don't have to go to each individual company, look at the values, calculate the values yourself. You can just do it with the tool. And this is what we're going to build today in Python. And for this, we're going to start with or by installing a couple of libraries. So we're going to open up CMD or your favorite terminal of choice. By the way, let me just reposition my camera before I forget it. So scaling it down, putting it to the upper right corner. There you go. So the library we're going to need today is going to be, first of all, pandas. So pip install pandas. I'm not going to do that because I already have it. We're going to also install pandas data reader. So pandas data reader like that, pandas dash data reader. And last but not least, Yahoo Fin, which is for Yahoo Finance. And this is what we're going to use in order to get some more stock information. So this is how we do it. And we're going to import pandas data reader as web. We're going to import pandas SPD. We're going to import, or actually we're going to say from Yahoo Fin import stock info SSI. And then import datetime as DT. So our goal is going to be to just go through the S&P 500 companies and find the ones that match our criteria. Now, what the criteria is, we're just going to make something up. We're not going to use anything that is really meaningful here. We're just going to set some certain things that we want to have, and then we're going to find the companies that fulfill this. So first of all, we're going to have to get all the ticker symbols of the S&P 500. So for those of you who have watched already a bunch of the stock tutorials on this channel, you know that we always use the pandas data reader to load the data from the Yahoo Finance API for specific companies. And we do that by specifying the ticker symbols of the individual companies. Now, the S&P 500 has 500 companies, and we need the ticker symbols of those. And how do we get them? We just say tickers equals si dot tickers SP500, like that. So now we have the tickers. Now what we need to do is we need to specify a time frame that we're looking at. So what we're going to do here is we're going to compare the performance of individual stocks to the performance of the S&P 500 as a whole. So we're going to look at which stocks beat the market, which stocks underperform, and so on. And then based on that comparison, we're going to make a decision. So we're going to say start equals, and we can say dt.datetime, and you can specify a date if you want to. So you can say, for example, 2020, 1st of January, or we're just going to look at the last year or the last 365 days. So dt datetime now, and what was it? Minus dt time delta days equals 365. So basically from now, minus 365 days is the start, and end is just going to be dt datetime dot now. There you go. So again, as I said, if you want to have a specific date, you can just say dt datetime 2020-11, for example, if you want to. Now we're going to first load the S&P 500 data frame. So we're going to load the information about the S&P 500, and then we're going to compare it to the individual stocks. So first of all, we're going to say SP 500 DF is going to be web data reader, and the symbol is this symbol here. I'm not sure what it's called. Hat. at least in mathematics, it's called hat. Then GSPC, this is the ticker symbol of the S&P 500 ETF. We're going to load it from the Yahoo Finance API from start to end. There you go. And now we're going to say S&P 500 data frame, and we're going to calculate the percentage change. So we want to know, okay, the closing value, the adjusted closing value, how much does it change from day to day? So what we're going to do is we're going to say S&P 500 DFPCT change is going to be SP 500 data frame adjusted close dot percentage change. So this is already a function that is part of pandas. We don't need to implement it, or actually a method, not a function. And what we want to know in the end, the final thing that we are actually interested in, is the return. So over that time frame, what was the actual return? And we're going to get that by saying S&P 500 return equals S&P 500 data frame percentage change plus 1. And we're going to have the cumulative product. So cumprot. And we're going to pick the last value because we're interested in the final return. So that is the return. That is how we calculate it. And now what we're going to do is we're going to do the same thing that we did here for all the individual stocks, and then we're going to compare them to the actual returns of the S&P 500 ETF. So we're going to say return list is an empty list first, and then we're going to craft the final data frame. The final data frame is what we're going to look at in order to make buying decisions. We're going to initialize it here, but we're going to use it later on. So I'm just going to define it. We're going to say final DF is going to be PD data frame. And the columns are what is important here. So we're only going to define the columns here. And what things are we interested in? You can decide for yourself. You don't have to use the strategy, quote unquote, that I'm using in this video. By the way, because I forgot to mention it, this video is not financial advice. Don't listen to me when it comes to financial advice. I'm a programmer. I'm a computer scientist. I'm teaching you programming. Don't listen to me in any way when it comes to stock investing, crypto investing, anything. I'm not responsible for any losses that you make, also not for any gains that you make. So don't listen to me when it comes to financial advice. It's just an important disclaimer here that I always need to make on YouTube. So what we're interested in here is the ticker column. You want to have a ticker symbol. We want to have the latest price. Latest price. We want to have a score value that we're going to define in a second what the score means. I'm just adding it here. So score basically is going to be how it compares to the S&P 500 returns. Then we're going to have the PE ratio. We're going to have the PEG ratio, which is PE and growth. So price to earnings ratio and price earnings growth ratio. Then we're going to have the moving average SMA for 150 days. We're going to have the moving average for 200 days. And we're going to have 52-week low and 52-week high. Again, you can just pick 2 of those if you want. So you can add 100 more values here. Those are just the columns that you want to make your decision with. So if you don't care about the moving averages, if you don't care about the PEG ratio, use something else. You know, maybe you only care about PE ratio, score, and 52-week low, nothing else. So depending on what you're interested in when you're screening for stocks, this is what you put into those columns here. In this video, I'm going to use those just because I think they're interesting, but I wouldn't say that this is necessarily what you should look at when you make investment decisions. So this is more about programming here. All right, so now we have that, and we're going to say for ticker and tickers. So for all tickers that we have from the S&P 500, we're going to say data frame, this is just going to be a temporary data frame, is going to be web data reader. And we're basically going to load the information for the ticker from the Yahoo Finance API, the same way we did it above, start to end. So the same thing that we did here with the S&P 500 as a whole, we're now doing for all the individual companies. So we say df to CSV as well. By the way, this is not necessarily something that you have to do. You can also just keep it in memory all the time. But later on, it's just easier to have this CSV file that you can just open if you want to do something with it. So I like to save the stuff into a CSV file. And we're going to call this stock data / ticker.csv as an f-string formatted. And then we're going to calculate the percentage change here as well. So PCT change is going to be adjusted close dot percentage change. And the return is going to be, again, the cumulative product. So stock return is going to be DataFrame percentage change +1 dot cumulative product last element. There you go. So that is it. And now the only thing we need to do is we need to calculate the returns compared to the S&P 500. So we're going to say returns compared is going to be rounded the stock return divided by the S&P 500 return, rounded to 2 decimal places, and then we're going to return to add this thing to the return list, which is up here. So we're going to have all the returns up here in this list. So return list, append returns compared. So that is how we basically do that. All right, so in the next step, what we're going to do is we're going to filter out the best performers. Now, you don't need to do that. This is just one decision that I make in this video to make a decision. You can also say, I want to have the worst performers, or I don't care about the performance compared to the S&P 500. I care about moving averages, and I care about PE ratios and so on. If that is the case, of course, you can skip that step, but I'm going to do it here just to show you how you would do something like that. So we want to know what are the best performers here. And how do we do that? We say best performers equals, and now we create a new data frame. So we say data frame, and now create a list of zip. Now, if you don't know what the zip function does, I have a video on this channel. I don't want to go into too much details here because this video is already going to be a little bit longer than usual, so I'm not going to explain the zip function in detail here, but I have in my advanced Python tutorial series, or I think it was in Python tips and tricks, one of the two, I have a video on the zip function. So if you want to know what it does, just look into it. We're going to zip the tickers and the return list, and then we're going to say the columns are just going to be ticker and returns compared. And now what we're going to do is we're going to say best performers score is going to be best performers returns compared. And we're going to use the rank method. The rank method basically does exactly what we want. We want to have the best performers. So we want to know, okay, when we compare the returns, which returns compared to the S&P 500 rank the best. So we're going to say rank, we're going to say percentage equals true because we don't want to have absolute values, you want to have percentage. And we're going to multiply this with 100 because we want to have the actual percentage values here. And now we're going to say best performers, we're going to cut out the rest, so we're going to only leave the best performers, is going to be best performers. And here we now have to specify the criteria. And the criteria is going to be that the best performers score must be larger or equal to the best performers score dot quantile. And here you can specify what you're interested in. The top 30%, the top 20%, the top 10%, the top 50% maybe only. So the quantile basically means from that point on, everything, or what would you say? If you pick, let me explain it with an example. If you pick the quantile 0.8, for example, 0.8. That means that you're picking the top 20% because you're going to the 80% quantile and you're saying, okay, everything below that is worse, and I want to have only the top 20%. This is how this method works here. So we're going to pick 70%. So we're going to actually pick the top 30%. Those are going to be the best performance. The top 30% when you compare their returns to the S&P 500 returns. Which does not necessarily say that this is a good decision, because after all, maybe the worst performers are going to have better performance in the future, whereas the best performers are going to go downhill. So you don't know, but this is just how you would do it if you choose to pick that investment strategy. And now what we're going to do is we're going to actually go ahead and calculate all the criteria for those best performers. So if we don't have a stock in the best performance, we're not even going to consider it. But those best performers, we're going to apply to them the criteria that we're interested in. So we're going to say for ticker in best performers, but not in best performers in general, but in best performers ticker. So for those tickers, we're going to load the CSV file. So we're not going to, again, use the Yahoo Finance API up here. We're going to use the CSV files that we have created by using this DataFrame.toCSV. And we're going to say try, so that if we get an exception, we're not gonna crash the script. So try except, I'm going to use pass as a placeholder here. And we're going to say try DataFrame equals pandas.read CSV. And we're going to read stock data. Was it stock data? Stock data, yes. / ticker.csv. And index column, we're going to set to 0 here. So this is going to be the data frame that we load from the CSV file. And now we're going to calculate the moving averages. So we're going to say moving averages, and we were interested, I think, in 150 and 200. So we're going to say moving averages is just going to be 150 and 200. You can add also a bunch of more numbers here. And then we say for MA in moving averages, data frame SMA underscore plus string of MA. So in this case, it would be SMA 150, SMA 200. And once we have that, we say equals round, and we're going to get the adjusted close value. And in order to calculate the moving average, we need to aggregate those values and apply the mean function. So we're going to say dot rolling. This is how we do it in pandas. We say dot rolling, so basically aggregating it. The window that we use, so the time frame, is going to be MA, so 150 elements or 200 elements. And then on that, we're going to apply the mean function. Comma 2. So basically, again, rounding it to 2 decimal places. There you go. So now we have the moving averages, and now we can also get all sorts of different values. So for example, we want to have the latest price. The latest price is going to be adjusted close and the last value. That's simple. The PE ratio is something that we're going to load from the Yahoo Finance stock info module. So we're going to say PE ratio is going to be float of si.getQuoteTable. And we want to get from that quote table the ticker symbol. And from there, we want to have PE ratio TTM. By the way, if you want to use different values and you don't know what the exact string is, you can just look into the stock info documentation, or you can, I think there's a function that you can call, or basically what you can do is you can just print si.getQuoteTable ticker, and then you're going to see in the dictionary what kind of fields you can access. So if you're interested in other statistics here. And then we're going to also get the PEG ratio, which is going to actually be the same. No, it's actually not the same because it belongs to a different function. So PEG ratio is float of si.getStatsValidation, valuation, sorry. And here the ticker, and this one is a little bit more complicated because here we don't actually access a string, so we don't say peg ratio, but we have to access the individual fields. Again, here what you do if you want to look at the different fields is you say print si.getStats valuation ticker, and then you can see, okay, what is where. In this case, I have already prepared it for this video. The peg ratio is at 1:4. So this is how you get the peg ratio. Again, if you want to understand what you're doing, just call this function and print the result. I'm not going to do it here. Now the moving average 150 is going to be df SMA 150 -1. Same thing for the 200. Code is getting quite big here. And now we're going to also get the 52-week low and the 52-week high, but since we cannot start with 52 as a variable name, we're going to say low 52-week, which is going to be rounded the minimum of DataFrame low from -52 times 5. I'm going to explain the calculation in a second, up until the end, rounded to 2 decimal places. Now what we're doing here basically is we have 5 days a week stock trading, 52 weeks, and we don't want to get like 365 instances, because then we would get also Saturdays and Sundays, which are non-existent, so we would actually look at more than 52 weeks. I don't even think that that is 100% accurate, because some days you just don't have trading, so maybe some special holidays or something. But this is a better estimate than using 365. So we're going to do the same thing for the high. So high 52 week is the same thing with high and with max. And besides that, we're going to also get the score. So the score is going to be round of best performers, ticker equals ticker, and from that instance, the score, which we're going to convert to a list, and we're going to pick the first instance. So basically, we're just saying, okay, get the ticker symbol of, or get that instance where the ticker symbol is ticker, get the score value, and then turn it to a list and pick the first value. This is just how we get the score that we calculated before. And now we can start with the conditions. So now we can specify what do we actually want to have in order for a stock to be accepted as something that we're interested in. So I'm going to say, for example, condition 1, and here you can choose whatever you want. But I'm going to say condition 1 is just going to be that the latest price is going to have to be larger than the moving average of the last 150 days, and this has to be larger than the moving average of the 200 last days. So this is basically saying latest price has to be larger than that, which has to be larger than that. One condition that you could specify, for example. Then we could also say, okay, the latest price has to be larger or equal to 1.3 times the 52-week low. So we have to be above that low, and we want to have at least 30% above that low. And we can also say condition 3 is going to be the latest price has to be larger than at least 75% of the 52-week high. So high 52-week. And then we can also say condition 4 equals not latest price, but PE ratio has to be less than 40, for example, which is quite liberal anyways. And the PEG ratio has to be less than 2. Just some criteria that we could apply. Now, in order to actually apply this condition or those conditions, we now need to use the final data frame that we created up here. So we're actually going to now get the stocks that apply here. And we're going to say, okay, if condition 1 and condition 2 and condition 3 and condition 4 and condition 5 apply. If all those 5 apply, then we're going to say final data frame equals final data frame dot append. So we're going to add to the final data frame, to the screened data frame, we're going to add a dictionary here. And this is going to be the ticker is going to be the ticker. The latest price is going to be the latest price. By the way, when choosing these keys here, you need to make sure that you're using the same keys that you have chosen up here in the columns. Otherwise, it's not going to work. So the latest price is the latest price. The score is the score. The PE ratio is the PE ratio. The PAG ratio is, guess what? The PAG ratio. The SMA 150 is going to be the moving average 150. The SMA 200 is going to be the moving average 200. And the 52-week low is going to be the low of 52 weeks. And the 52-week high is going to be the high of 52 weeks. And we're going to ignore the index. So ignore index equals true. There you go. That is how you add it. And if for some reason we get an exception here, we're going to say except exception as E. We're going to print this exception for the ticker symbol. All right, so last but not least, all we want to do is want to sort by score. So we're going to say final data frame dot sort values, and we're going to sort by score. And we're going to score descending, so ascending equals false. And what we're also going to do is we're going to say pd.setOption display max columns to 10, or actually, yeah, 10 should be enough, so that we just see all the columns and not just dot, dot, dot in between. And finally, we're going to print the data frame so that we actually see the result, and we're going to save it into a CSV file. So final df to CSV final.csv. And that is it. Now we could theoretically just start the script and let it run over the 500 companies, but this would take a very long time. And of course, if you want to make an actual decision, it's worth the time. You just leave it running for a couple of minutes, maybe an hour. Even though an hour is way too much, I think it's going to take like a couple of minutes. But in this case, I don't want to do it. I don't want to run through all the 500 companies. We're just going to see that it works. And for this, we're going to say counter equals 0, and we're going to just say counter plus equals 1, and if counter is, I don't know, let's say 10, we're going to break, and we're going to use those 10 companies as the basis. So I'm just going to run this so that you see that it works. Is this actually the right program here? Let me just terminate it and run it before I execute another main file. Yeah, it wasn't the right one. That is important. So now it's going to run, and we have a problem here. No such file or directory, stock data ACSV. This is in line 22. To CSV, what is the problem? Oh, I think we need to create a directory first. So stock data needs to be created here, and now we can run this again, and hopefully it works. Yeah, seems to work. So we should also probably see that, or maybe if I stop it or when the script is done, we're going to see it. What do we have here? No such keys, display max columns. Oh, I think I actually have a typo in there. Of course, because it's not columns, but columns with an N in between. But it actually reached the end of the program, which means that everything in between worked, right? So let's see. Didn't even take too long. But okay, for 10 companies, it shouldn't take too long, actually. So what do we have here? The only company of the first 10 companies that survived here was Apple. We have a price of that. We have a score of 80. We have a PE ratio of almost 30. We have a PEG ratio below 2. So it seems like Apple fulfills the requirements. So we can also ease the requirements a little bit. Let's say the only thing that we're actually interested in is PE ratio below 40 and PEG ratio below 2. So we just check for condition 4 and 5. Maybe we're going to find more stocks if we do it like that. So let's run this again. And of course, if you run this on 50 companies or on all 500 companies, Apple is not going to be the only one that fulfills this criteria, but for the first 10. Also, you need to think about the fact that we are cutting off the worst performers, even though some condition might be fulfilled by them. So maybe they have a PE ratio of less than 40. Maybe they have a score or a PEG ratio below 2, but the score is not enough to even qualify. So in this case, even for those two conditions, Apple is the only one fulfilling it. We can actually try to increase the counter here, the counter limit to, I don't know, let's go with 30. Might take a little bit longer, but then I'm going to just talk about what we're doing here a little bit. So we're now actually just asking for PE ratio less than 40 and PEG ratio less than 2. Not too difficult to fulfill, given the fact that PE ratio of 40 is actually quite high already, and PEG ratio of 2 is also not necessarily something that is considered a low value. But while it's loading, let's recap what we're doing here. We're loading the ticker symbols, we're specifying a time frame, we're getting the performance of the S&P 500 as a whole, of the stock index. We're preparing a final data frame. We're going through all the tickers in the S&P 500 if we're not limiting it with the counter here artificially for demonstration purposes. So this would not be included in the final code. We're calculating the same returns or the same change for all the individual stocks, comparing it to the S&P 500 returns, determining the best performance based off, or the best performers based off this comparison. We're going through all the tickers again, and then we're calculating all the important values like moving averages, like last price, PE ratio, PEG ratio, moving averages, 52-week lows, 52-week highs, and so on. And then we specify a bunch of conditions, 1, 2, 3, 4, 5. You can specify 20 conditions if you want to. You can only specify one condition, and then we apply those conditions. And if a ticker symbol, if a company applies or fulfills all those conditions, it's going to be listed in the final data frame, which we then sort by score in the end, and we set the option so that we see all the columns, and we print it, and we save it to a CSV file. And even though I explained all that, we're still not done with the actual calculations. So, oh, there you go. For some reason now, Apple is not here, probably because Apple is no longer in the best performance. So ADM and AMAT, I don't know both of them, are better performers than Apple. So Apple didn't actually qualify for the best performance, because we already know that Apple qualifies for condition number 4 and 5, but it was filtered out even before we get there because it's not part of the best performance. So those two were part of the best performance, and also PE ratio less than 40 and PEG ratio less than 2. So in this case, we screened those two stocks. Again, you can just ignore that part if you're not interested in the best performance. Maybe you even want to have the worst performance for some reason, so you can just turn this thing around here. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Of course, also let me know if you want to see more finance related stuff. I have some videos prepared, so I'm going to release more finance stuff in the near future, but let me know what you think about those finance related videos, stock trading, crypto trading, and so on, analysis, algorithmic trading strategy, portfolio visualization, and so on. Let me know if you want to see more of that in the comment section down below. And of course, don't forget to subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.